everyone, welcome back to SAT Math Question of the Day. Here's our question of the day. Please try it, pause the video, come back, and we will try to do it. Okay, in this figure, J, K, L, and J, L, K, and J and M are both right triangles. Which of the following is equal to this side, K, L? Okay, so let's just look at all the choices. Wow. Oh, this is a trig question. Wow. Ooh, now everything's against the angle Y, isn't it? Everything, look at all the answers. All the answers are off of angle Y. So this is our angle of choice, right?
Yeah.
So, oh, interesting. Oh, wait. But angle Y equals this angle. This angle, right. Oh, we got to know that. Right, because look, angle Y is not on the same triangle as this triangle. So there's a problem there. So we got to find an angle that's in this triangle because KL is in this triangle. So they're making us think. So that's also angle Y. Okay. Now we have to.
Now, how could you eliminate choices A and B?
I don't know. I haven't started looking at it yet. Well, first of all, the units. Oh, I see what you mean. The units of this have to be distance. So this is distance over distance. It can't be those two. You're right. It can't be those two because you're looking for if this is 3 inches, if you have an inches here and an inches here, they cross off. So you don't get inches as the answer, right? So KL, the units of KL must be in, what do they call them? Units of distance or whatever, right? I'm going to get rid of that 3 inches.
Yeah, units of distance. So if you're you're American, they'd be inches.
Right.
If you were anywhere else in the world, it would be centimeters or meters.
So that was very...
Or nanometers.
Right, okay, fine. So that
could be light years. It could be light years. No, then you have trouble relativity.
Just stop. Okay.
Yeah, curvature of space if you...
Yeah, okay. Okay, I don't know if I would have noticed that at first, but maybe I would have. Which means now it's just a little choice between the tangents. So
it's a matter of how to apply the definition of tangent.
So why don't we just, rather than look at it, it's easy enough. Let's just do a tangent of y is opposite JL over KL. So the answer is
wait. So please say it. Opposite. So according to the tangent, according to angle theta, according to angle y, the opposite side or opposite of side KL is this one, and the adjacent side of the right triangle
relative to the angle Y
to the angle Y,
and we'll make it
is this one.
Pink. How about a nice pink angle? Pink angle. Right.
So let's see. So the tangent is now what the way I remember it is using the terms rise divided by run.
Okay.
So here y is on its side. It's on the top. But if you had this triangle, like this. Oh, let's see. I'll do it this way. Yeah, if you had it,
making it harder.
No. I like to say rise over run.
Yeah, but that's so confusing.
No, that's what I like to say. There's y.
Fine. You like
opposite over adjacent. This is as you go from here to here. There's the run.
Right.
And then as you go in the run direction, you go up, called the rise.
Right. Yeah.
But here the angle is facing downward rather than to the side.
Right.
And so I think you're right. It's better to say opposite over adjacent.
Look, if you're dying to do that, take the paper and rotate it. Oh, I forgot. This is digital SAT. You don't have a paper. You can't
pick up if it's on a tablet computer, you could rotate it.
Yeah. If it was on paper, you could do what Seth did.
Yeah.
But forget it. He's just making it hard.
Yeah.
So anyway, what's the final answer? We have to solve
KL is the question
KL
mark
is equal to JL divided by tangent.
Yeah. So you swap around these guys,
So it has to be this.
And KL equals JL divided by tangent Y.
So
Okay.
there's a lot of stuff going on here. First, you have to know that these two angles are equal. Why are they equal? They're equal because they're, believe it or not, they're corresponding angles. We extend the parallel lines. These lines are parallel. Why are they parallel? Because they are both they both hit this bottom line here, the JN thing, both in right angles. So these two lines are parallel. If these two lines are parallel, then these guys are corresponding angles. So you had to know that. And then you have to know the definition of the trig functions. You also had to know what set did, which is cross these off. They don't make sense.
Well, you could have gone directly from the trig function, and observed that the other two aren't the answer.
Right. Yeah. You could just go through that. Right. Yeah. That's what a lot of people. It's probably responsible what I would have done. And then you're left with these tangent choices, and then you apply the rule, the definition of tangent, as opposite over adjacent. You know what? The way I like to look at it, I like to look at it this way. I think that we've all been in restaurants. You want to sit by the water. You like the in window view when you sit by the water, right? Near a lake or a river or an ocean, right? You listen to a restaurant. You want to get a window view while you're eating. So first of all, the hypotenuse is off limits. Let's say your table is here. The opposite side is the side you would like to look at if you wanted to see the ocean or the view in a restaurant. Like your table's sitting here. You look out the window. You see everything. The adjacent side isn't as nice. This side, basically, you're sitting, not that it's not nice sitting with your friends, but, you'd be looking at your friends over here. You wouldn't be looking at the ocean. So that's how I view.
Well, I mean, these trig functions in terms of the ratios of lengths of edges in a triangle.
Right.
The triangle, the only kind of triangle for which that relationship is the right triangle.
Yeah, that's why they had to say that.
Yes, so it must be a right triangle. Right. Where the trig functions have this simple interpretation of ratios of various pairs of edges. Those are in a right triangle.
Right.
There are more complicated relations between lengths of sides and trig functions of angles for arbitrary triangles.
Yes, and you do that in either late algebra 2 or pre-calc, and I don't think that stuff's on the regions. That's
the law of sines, the law of cosines.
Law of sines and cosines, right?
Yeah.
Okay, so I think we maybe done enough here. In terms of the approach, I mean, yes, if you didn't see that these ratios don't make any sense, then you would just go through and you would confirm that these are wrong. It's a little more work, but it was very efficient to notice that these cancel out, and they don't make sense. Okay, and of course you have to know the definition of tangent to do this.
Yeah.
Okay, so I guess we could check and see how they did it. It'd be interesting how they got rid of A and B. So let's see how they did that. Normally we don't look at why they reject an answer, but let's see. Okay. Oh, look at that. They say incorrect for 1. Notice that those triangles are similar. This is the wrong trigonometric function for the situation. They didn't say that the ratio doesn't make sense based on unit analysis. That's too bad.
Yeah.
Okay. So let's see how they do. On the positive side, 4 steps. Okay, they share angles, so they both have right. Okay, the triangles are similar. Oh, therefore, they should have. Don't you think they should have shown the whole problem? No, whatever. I mean, oops, I paused the screen share. No way, come on. How did I pause the screen share? Wait, why did I pause the screen share? That is so annoying. Oh, resume share. Sorry. Okay. Yeah, I don't know why they just didn't show both triangles. It wouldn't have hurt. But anyway. Okay, since JL is opposite YK, they say that's the tangent. Yeah, but they could have also said, but they already knew the answer. Why couldn't they have also said that sine of, oh no, they could have brought in cosine of y. They could have been in cosine of y. Cosine of y is jk over kl. So why'd they choose the tangent unless they knew the answer?
But JL over KL.
Yeah, like why? What was their justification to bring in the tangent?
Well, cosine JK. There's no JK route. There's no. Where's
No,
JK?
the cosine of y. No, the cosine of y. Sorry, the cosine of y. This problem's getting me upset. The cosine of y is KL over JK. Right? Cosine of y is KL over JK, right?
Oh yeah, okay, yes, indeed.
Yeah. So why did they? Yeah. Or they don't give a justification for why they just brought this one in when you could have also brought this one in.
No, they're different.
No, I know, but this gets you to the answer faster. But this requires you to have noticed that the tangent's involved in the answer, which they didn't say how they knew to focus on the tangent.
Because well, it's because the unknown was KL.
Yeah, but right here, the unknown is KL.
It's because the unknown is KL.
Yeah.
And the only relevant choice involved JL. There was no choice. Well, the choices that involved
really
KL
above. There were no choices with JL above? No, there was one with JK.
Well,
question
they're
one.
Both. Yeah.
Question one had JK in it.
Yeah.
But in their answer, they didn't reject question 1 and 2. Right?
Yeah.
In starting with step 1, nowhere did they reject the choices for JK. And yes, once you get rid of the choices 1 and 2, of course the tangent's involved. But nowhere in their solution are they saying, like, step by step. They're not removing the sine and cosine from the choices.
I don't understand your point.
Okay, why did they write tangent? Why all of a sudden they just came right out and said tangent of y? Why?
Well,
without justification.
Why did they pick expanding tangent of y as opposed to
cosine of
sine of y or cosine of y?
That's exactly right. Well, they don't justify that. They don't justify that.
Well, there are three things they could have picked.
Yeah.
If the unknown is KL, you could relate KL to other lines. The KL is related to JL by means of the tangent.
Right.
And KL is related to JK by means of the cosine.
Yes.
So,
I know.
So why'd they pick tangents?
That's what I was asking.
Well,
what's their justification?
It's maybe looking ahead.
But they didn't say that. They didn't say that in their answer. They didn't say looking ahead.
Yeah. Oh yeah. Right.
They didn't justify why.
They didn't say please look ahead.
They didn't say, looking at the answers, the tangent is probably involved.
Yeah.
Or anything like that. They just all of a sudden threw out tangent of y. Why you couldn't
pulled
have done
it out of there. They pulled it out of the hat.
They pulled it out of the hat. Right.
That's a very annoying thing to do when you're teaching someone math, to just pull it out of the hat.
Absolutely. Very annoying. And it doesn't, right, exactly. So, we try to please try to justify everything as you do your math problems. So then the rest is history, right? Yeah.
Yeah.
Right.
Yeah. So the approach idea here is that to notice when a question asks is a certain quantity. The question is, what does a certain quantity equal? Well, there are many, many answers
Absolutely.
to a question like that.
Yes, there are.
But on the SAT, the job is not to find any valid answer, but to find among the choices.
Yes, you know that.
Which of the choices is an expression that is equal to the quantity that's given?
I mean, there are.
So the approach is that a question like this, do not willy-nilly find new expressions for the quantity they're asking you to compare. But the approach is to look at the expressions that they give you.
That's right.
And then the expressions, and then seek reasons, simultaneously explore for reasons why an expression they give you cannot be the correct one, and at the same time look for a reason why an expression is equal to the one they give you.
Yes.
And it may take several steps because there are several choices.
Right.
But again, SAT questions are almost or completely reliably consistent.
Yeah, we know.
And unlike real questions.
Okay, yeah, I know. You say
so as soon as you find a choice that gives an expression that is equal to the given quantity, you're done with solving the problem.
Right. Notice
and then you could use you could use any other insights in that correctness search and elimination process. Yeah. So I apply the elimination because the first two distractors had the wrong units.
Right. Yeah. In this problem, you definitely want to take the approach of looking at the answers first before diving head into the problem.
Yeah. So notice that among the two remaining answers, both of them related the same two quantities by means of the tangent of the angle.
We said that already. Okay, we're done.
Right?
Yes.
So therefore that justifies why you would head for the definition of the tangent of the angle y.
Yeah. Of course.
Well, that answers your question. Why they pulled tangent out of the hat.
I know the answer to it, but they didn't explain it in their answer. They pulled it out of thin air. They should have justified why. Yeah. They said, let's consider the tangent function because that looks like it's going to be involved in the answer because choices 1 and 2 don't look right. Something like that, but they didn't say that.
They don't do that.
They didn't say that explicitly. But anyway,
that's why we are your hero. That's why we are better heroes.
Yeah, well, that's why this problem. The approach is definitely look at the answers first in this particular type of problem. Okay, so I guess that's it. So
that's it.
We've abused our audience enough. I'm Joel. I have a PhD in mechanical engineering. Seth is brother Seth. He has a PhD in math from MIT, a professor emeritus at SUNY Albany. Retired now. We're here to hopefully offer different approaches on how to actually do math SAT practice questions and maybe even SAT questions. The approach we promulgate, we advise is going to Khan Academy and taking one of their classes, either the digital and non-digital SAT class. It has hundreds of questions that you could practice on that are sanctioned by the SAT people, and then go and start taking practice SAT tests given out by the SAT. So I think we're done. Just finishing off. Just please send us comments, dislike our videos. And if you have any SAT math questions, email them to us at satmathquestionoftheday@gmail.com. And tomorrow is Thursday already, right? Wow. So tomorrow we are planning Throwback Thursday. So that's always a nice thing to do on Thursdays. Okay, everyone. Have a great day. Take care, everyone.
Okay,
Bye-bye.
everybody.
Bye-bye.